So when we met last week, the last thing that we talked about was how to multiply polynomials. And we talked about what we do with our exponents, what an exponent really means. We had talked about if I'm adding like terms, that all I'm doing is adding the coefficients. That variable and that exponent don't change at all. But if I'm multiplying, then I do what with the exponents? Remember? Add them, because it's telling me how many of these are being multiplied together. So I just add them up. So if I'm multiplying monomials and polynomials, as long as there's a monomial is how many terms, by the way? Just one term. So if I just see one term in front of a parentheses, and inside the parentheses there's a plus sign or a minus sign, then I use the distributive property. Everything in that parentheses gets multiplied by what was outside, and I keep up with all those sign rules. Do we want to practice one of those just to make sure we remember how to do it, or do you think we've got that part? Let me see. I'm going to put one up here just for practice sake. Let's say we had a 3x, and in parentheses I had an x to the third minus 2x squared. Let's see if you can tell me what that would equal if I were to distribute and multiply through. And while you're figuring that out, let me remind you, if I see two terms inside the parentheses, my answer when I finish the distributive property should be how many terms? 2. Same number of terms is how many are in the parentheses. So what would 3x times x to the third be? Very good. Because what's the number in front of this x, even though I don't see it? It's a 1. 3 times 1 is 3, and x times x to the third is x to the fourth. I've got one of those x's, and I'm going to multiply it times 3 more of those x's. That's a total of 4. Now, what would the second term be? And what sign do I want to put down? Good, because that's a subtraction sign. Remember, the sign that's in front of a number stays with the number. You can think of this as a negative 2x squared that gets multiplied by a positive 3x. So I'm going to have a minus what number? 6, and then what? X to the third. Okay, give me a quick signal. Are we here, here, or here on distributive property? And keeping up when we have variables and exponents. Okay, so then we talked about if we have polynomial times polynomial, and we looked specifically at a binomial times a trinomial. We said we could use this little rectangle or box method. And the way we did that is we counted up how many terms we had for each factor. Factors can be what's inside of parentheses. And since there were 2 terms here, 3 terms here, we made a box that had 2 rows and 3 columns. And this just helps us stay organized because we're using the distributive property, but we're having to use it more than once. And we said like terms would show up on the diagonal. And after we get the box filled out, then we can add up like terms and pull it out. Okay, so we're going to, excuse me, practice more of that. But we're going to take it down to a binomial times a binomial, because we probably will do that kind of multiplying most often anyway. And we said you can use FOIL. You probably learned that. I'm sure you did back in high school, which means what? F is first, O is outer, I is inner, and L is last. And if you remember FOIL and you just want to do it that way, you can. But if we do what we talked about, this first parentheses has 2 terms. So if I put 4x plus 3 beside each row, and then on the columns, I put an x here and a plus 2 here, then I can multiply, fill in my box, and come up with what that is once I get those 2 multiplied. So see if you can tell me what would go in this box right here. 4x times x is 4x squared. Good job. What goes in the box to the right? Well, I got to multiply them. So what's 4x times a positive 2? 8x, right? So plus 8x. Okay. What's going to go down here? and it's positive, right? Plus 3x. And then what's going to go in the bottom right? Now, do you see any like terms? Yeah, we said as long as this is in descending order, in other words, we had the plain number at the end, and if the first terms are both x terms, then we see our like term show up on the diagonal. So if I pull it out of the box, how would I write my final answer? My biggest exponent is on what term has the biggest exponent? The 4x squared, right? So I write it down first because we want to put it in descending order, biggest exponent first. Then what do I get when I add these two? Plus 11x, good. When they're like terms, I just add up the coefficients, keep the same variable, and then what goes on the end? Good job, okay. So it does not matter to me if you want to do FOIL or if you want to do the box. I like the box just because it keeps me organized. Oh yeah, you're going to have to, well, not that you have to use the box, but you have to be able to multiply these together. So let's just do this one. I want you guys to work on it. I'm going to walk around, take a peek at what you're doing. All right, so most of you, it looked like we're drawing the box. I'm going to put a box on here. If you didn't draw a box, it's okay. And if I put 4x minus 3 over here and 2y plus 5 up here, what went in your first box on the left?
4x.
The 4x times 2y became, good, 8xy. We just multiply all those pieces together because the variables aren't the same. It just stays x times y. Now, what went in the top right box? Plus 20x. What went down in the bottom left? Good. And what went in the bottom right? Remember to multiply. -3 times a +5 is a -15. And nothing combined. There were no like terms. So if I pull it out of the box, it's just 8xy plus 20x minus 6y minus 15. Now, does it matter the order I write those four terms in? No. There's not anything. I would probably still put the 8xy first, but these two in the middle, if they're in a different order on your paper, it's perfectly okay. All right. If you happen to have more than 2 factors, if there are 3 factors, you just pick 2, do it first, and then take that answer times the third one. I don't think we're going to see this very often, but I will give you one example just so you understand. That would mean if I had y squared times, and then I had 8y plus 3 in parentheses, and I had 2y plus 1 in parentheses, I'm going to do it one of these 2 ways. I can either choose to distribute first, and then I'll have a new binomial times this binomial, or I could do the binomial times the binomial first, and after I get that, I could distribute the y squared through. It's saying it doesn't matter which 2 you pick, you're just going to pick 2 and then multiply it out. So if I did it this way, can I distribute pretty easily through this first parentheses? Okay, so y squared times 8y is what? 8y to the third. And then y squared times +3 is what? Plus 3y squared. Now here's where you got to be careful. I don't distribute through both of these parentheses. It's sort of like if I had 2 times 3 times 4. What does that equal? What do you think that equals? 24, because 2 times 3 is 6, and 6 times 4 is 24. I don't multiply 2 times 3 and then multiply 2 times 4 and then take those 2 numbers and multiply together. Same thing here. You don't multiply the y squared times both of the parentheses. You only pick two factors, just like 2 times 3. Multiply those together and then take that answer times the other leftover factor you hadn't used yet. And then you could draw yourself your box and multiply that out. Does that make sense? That's just a word of caution. If you had more than 2 factors, then make sure you multiply 2 of them together and then don't touch the third one until you get to the end. Now, fractions could be there. You're probably not going to see them very often. Don't let them freak you out if you do see them. But I want to point out what this means. What do you think you would do if you had x plus 5 in parentheses raised to the 3rd power? There you go. Remember what an exponent means. It's telling me that I'm multiplying x plus 5 times x plus 5 times x plus 5. I cannot cube the x and cube the 5 and add them together. That's not the right answer. I've got to write the parentheses 3 times, and then you can do what we just talked about. Pick 2 of these to multiply together. Take that answer and then multiply it times the other x plus 5. Make sense? Do we need to go through that together? Y'all want to see that or not? You want to see it? Okay. So you guys on your paper multiply x plus 5 times x plus 5. I'm going to give you a second to do that, and then you're going to tell me what it is, and I'm going to put it up here and we'll finish it out together. So you just do the x plus 5 times the x plus 5. You think you finished that multiplying on the x plus 5 times x plus 5? Let me see hands. Okay, got 1, 2, 3, 4, 5. Good. Okay, and those of you who finished it, how many terms do you have once you've cleaned it all up? 3. And is your first term x squared? Yes. So I'm going to show you real quickly. If you were using FOIL, just on these two, first times first is x squared, right? Outer times outer, what's x times 5? 5x. So I'd have a plus 5x. Inner times inner is another plus 5x. And then what is last times last? Plus 25. And did you have something you could combine? Yeah, 5x plus 5x is, so x squared plus 10x plus 25 is what you get when you multiply those first 2 parentheses together. Did y'all get that right? No. If you didn't, do you see why you didn't?
Yeah. So it's the first x times first x. Then the first x times 5. Then the first x. No.
This is if you use FOIL, okay? If you're using the box, which is probably easier, which way did you try to do it?
Just like that.
Okay, I would go to the box. We're going to use the box now to multiply this, x squared plus 10x plus 25 times that x plus 5. So how many terms do I have in this parentheses? 3. How many do I have here? 2. So I'm going to draw a rectangle. And I'm going to put 2 rows. I'll put the x here and the plus 5 here. And I'm going to make 3 columns. And I'll put x squared here, plus 10x here, and plus 25 here. Anytime I'm multiplying 2 terms times 3 terms, I wouldn't try to use distributive property in my head. I would make a box, okay? And what's going to go in this first box? X to the 3rd. X times x to the 2nd is x to the 3rd. What's going to go in the middle on the top row? Plus 10x squared, because x times 10x, x times x is x squared. What goes in the 3rd? Plus 25x. Good job. Okay, now let's go to the bottom row. 5 times x squared is, so plus 5x squared. What goes in the middle on the bottom? Good, plus 50x. And in the bottom right box, we have plus 125. Good job. Okay, do you see some like terms we can combine?
50x.
Oh, you know what? Darn. 10x times x, I left my square off. Let's fix that. So that's a 10x squared in the middle. All right. So now, there you go. And that was another thing that, remember how I said your like term should show up on the diagonal? When I looked and I saw, wait a minute, that's an x and that's an x. That was kind of a quick way for me to double check and see, oops, I made a mistake. So keep that in mind. Now that I have multiplied it out, I've seen where my like terms are. Let's pull it out of the box. So when this gets multiplied, it equals what? X to the third. Plus, when I add these two, I get, go ahead, Patrick, 15x squared. Plus 50 plus 25 is 75x. And then my last term is plus 125. Oops, let me see if I can squeeze it in. There we go. All right.
Leave it like that.
And that would be my final answer because I don't have any other like terms I can combine. I've got an x to the third, an x to the second, x to the first, and then a plain number, a constant. All right, give me a quick signal on multiplying polynomials together. Are you here, here, or here? Okay, so we're not all in the same place. I do see a lot of these, but I see some of these too. So let's keep practicing. This part says here are some shortcuts. Now I'm going to tell you this. I don't really necessarily want to teach you shortcuts. If you recognize a shortcut, you are welcome to use it as long as it's something when you do it, you're getting the right answer. If you are guessing and you think, well, I'm using a shortcut because I think I can figure this out, but you find you're not getting it right, do not try to use a shortcut. So talk to me about if I gave you x minus 5 in parentheses squared, what would probably be a logical way to find that answer? Do we know of a way we can do it even without using a shortcut? What? Say again? Say it one more time. Multiply it times itself. Excellent, Kelsey. Do not forget that exponent just tells you how many times you're multiplying this by itself. You want to write it out with 2 parentheses. And if I write it out with 2 parentheses, do you know what to do with it? What would you do? I'd make a box. So if I make a box, what would you put here? X. What would I put down here? And it needs to be minus 5, right? Across the top, I'd put x and minus 5 because one of the parentheses is going to go with the rows, the other parentheses goes with the columns. Are we good on this part of it? If you've got this, do you understand that you can go from here to here? Is that part okay? Because if there's anything you don't understand, please ask. Okay. What's going to go in this box? X squared. X times x is x squared. What's going to go in this box? Minus 5x top right. Bottom left is another minus 5x. And then a negative times a negative gives me a positive. So that's why that's a plus 25. Yeah, the more times you practice, the more sense it makes, right? So can you tell me, if I put like terms together, what is this going to equal?
A squared minus 28 plus 25.
Good job. X squared minus 10x plus 25 because here are my like terms. And I put those together. Okay. Now, if we look at the next part, there is also another pattern here that you might discover, but, well, I tell you what, let's make sure we don't have any trouble with C before we do F, because we're going to do both of those, but I want to do. Is the only thing you worry about on D the fraction? All right, well then we'll do D instead of C. How about that? So we look at one that does have a fraction. So if I have 3k minus 1/2 in parentheses squared, what would be the first thing you ought to do? Multiply it by itself. I'm going to write out what that means without the exponent. So 3k minus 1/2 times another 3k minus 1/2. All right. From here, what would you want to do? I put a box. Yeah, you don't have to put a box. I would put a box. Okay, so 3k. What do I need to write down here? Good, minus 1/2. Across the top row, or top the columns, I'm going to have a 3k and a minus 1/2. All right, so let's multiply and let's see what we end. Oh, why did you do that? Okay. Let's go to the green. All right, let's multiply. So 3k times 3k is, say it again? Very good, 9k squared. Okay, this is the one you might be nervous about. And I don't know for sure if I can do this in my head easily. So what I'm gonna do is write out, I'm multiplying 3k times a negative 1/2. Now, anytime I'm multiplying, and one of them is a fraction, I think I feel better if it looks like a fraction times a fraction. So what would maybe be a good thing to do with the 3k? If I put it over 1. Now, I don't see anything that would reduce because I don't know what k is. It's a variable, and I don't have any variables on the bottom. And a 3 and a 2 don't have any common factors, so let's just multiply straight across. What would 3k times negative 1 be? Negative 3, and then, yeah, I'm going to have a k here, over 1 times 2 is 2. And the k can be in the top of the fraction with the 3, or the k could be like the fraction times the k. All right, so if we may find it's a little easier if I leave it as negative 3/2 times k, because that's kind of what I need to know is what number is getting multiplied times k. And if I look at this for the bottom left box, I have negative 1/2 times 3k. Isn't that the same thing I just multiplied? So I know what goes in this box. It's what? The same thing I got here. A negative 3 over 2k. Negative 3/2 k. All right? Are you guys with me? So let's multiply a negative 1/2 times a negative 1/2 to see what goes in the bottom right box. Now don't add, let's multiply. Remember, if I multiply straight across, first of all, I'll tell you about the sign. What's a negative times a negative? Positive. What's 1/2 times 1/2? 1/4. Good job. Okay. Are we all right with what we have in the box? How we got there? Then let's do this. I see I have this negative 3/2 k plus another negative 3/2 k. Let's see if you guys can tell me what that should equal. Negative 3/2 k plus another negative 3/2 k. Now, first of all, would you say those are like? Yes, because they both have a k to the first power. So all I have to do is add the coefficients, the numbers that are in front. So I'm looking at my signs first, I see it's a negative plus a negative. What does that tell me to do to get my answer? Add them. So what would 3 halves plus 3 halves be? And we'll get the sign to the answer in a minute. If I have 3 halves and I add 3 halves, what do I get? Hang on, don't get too far ahead of me. Okay, if I add these together, they have common denominators. So 3 plus 3 is 6 over 2. And 6 over 2 reduces to 3. That's the number part of my answer. 3 halves plus 3 halves. 3 halves is the same thing as 1 1/2. So 1 1/2 plus 1 1/2 is 3. Does that make sense? Now, does that need to be a positive or a negative 3? Because a negative plus a negative, the signs were the same. I added the numbers and I keep the same sign. This is going to be a negative 3k. So my answer would be 9k squared minus 3k. And then what's going to go on the end? Plus 1/4. Does that make sense? That's the difference when there's a fraction. You'll just have to be careful when you multiply a fraction times something that's not a fraction, make it look like a fraction. And then when you do the addition part, you got to use your sign rules for that too. So that's a good one to go over. That covers a lot of what we've talked about. And instead of doing F, we have more of those down below. So let's just go down and we'll look at G first. And if I look at G, do I have 2 terms times 2 terms? Can I use the box? Yeah, I can use the box. So if I do that, if I put the first parentheses beside my rows, what am I going to put here? Y. What's going to go down here? Plus 3. Now let's go across the top and on the columns. First column will be Y. Second column will be minus 3. Okay, let's see what happens when we multiply through here. So what's going to go in this first box? Y squared. Let's go across that row. What goes in the top right? Minus 3y. Okay, go down to the bottom. What goes bottom left? And it's positive, isn't it? And then what goes bottom right? Good. Positive times a negative is a negative, and 3 times 3 is 9. Now, when I go to look for like terms, what do you notice happens? I have 1 positive, 1 negative, but the number and the variable matches. So if I'm adding a positive and a negative, different signs, I'm actually going to subtract those numbers, right? 3 minus 3 is 0. These guys cancel out, and I am left with y squared minus 9. Because remember, that was a positive 3 times negative 3, which gave me a negative 9. That has a special name. It's called the difference of squares when we multiply it out, because my first term is squared, my last term is squared, and there's a minus sign in between them. But I don't have to memorize any pattern. As long as I use the box, I can multiply those together and get the answer. Okay? Now, let's see if you guys can do I. I want you to try to figure out what 7p plus 2q times 7p minus 2q would equal. All right, let's check and see how you guys did. Most of you made a box. A few of you did foil. I'm just going to caution you. Those of you who are doing FOIL, do you find you sometimes make sign mistakes? If you do, because what you're having to do is keep up with more in your head than if you use the box. So if you're not always getting it right trying to use FOIL, I would draw the box. And if I draw the box, then I can put 7p plus 2q beside each row. My columns will be 7p minus 2q. Okay? And then when I multiply, what did you say goes in top left? Yes, 7 times 7 is 49, and p times p is p squared. Top right was, yes, because 7 times -2 is -14, and then p times q is just p times q. Bottom left, +14, and it doesn't matter if I put the p first or the q first. Remember, if I'm multiplying things together, 2 times 3 is the same thing as 3 times 2. So I'm just going to put the p and then the q. And then what went in the bottom right? Good. A +2 times a -2 is a -4, and q times q is q squared. Now, if these parentheses have the same thing in them, except one has a plus sign and one has a minus sign, what happens when we add up our diagonal? They cancel out. They're the same thing, except one's plus and one's minus. And that meant we wound up with 49 p squared minus 4q squared. Okay? So the last thing we have on these notes before we go into chapter 1 is a reminder of all of the sign rules. I'm sorry, not the sign rules, the exponent rules. So we have been using this guy here, the product rule. If we have something to a power times something else to a power, we add the exponents. Let me give you, a lot of times it's easier if you see it where they're not all variables. So if I had x cubed and I wanted to multiply that times x squared, what is that going to equal? He says x to the 5th. Do y'all agree? Yes, and the reason is this. Remember, x to the 3rd means 3 of these guys multiplied together times 2 more of these guys multiplied together. That's 5 x's being multiplied together. So the shortcut is, as long as the bases are the same, when I'm multiplying, I add the exponents. Now, anything raised to the 0 power, I have to remember equals what? Okay, let me show you again so that this would make sense. And to do that, it will help if we first cover this quotient rule. So let me just kind of go over this with you for a second. If we had x to the 5th, and I had that divided by x squared, what would that equal? He says x to the 3rd. Do you think he's right? Let's figure that out. Let's say I write out what x to the 5th means. That's 1, 2, 3, 4, 5 of these x's being multiplied together, right? Divided by, what does x squared mean? 2 of these x's being multiplied together. Now, if you think about what we know we can do if we have a fraction and there are factors involved, things being multiplied together, what does any number divided by itself equal? 1. If I have an x on top and an x on bottom, I can cancel that out because that means the same thing as 1. Here's another one of those I can cancel out. What's left? 3 of these guys. That's x to the 3rd. Now, what would be the shortcut if my bases are the same, it's a fraction, and I had exponents on there? What do I do with the exponents? I'm going to subtract. Now, keep that in mind. Let's go back to this rule so that you can see why something to the 0 power would equal 1. Let's say we had x to the 3rd over x to the third. Now, let's use this rule we just covered, the quotient rule. What am I supposed to do with exponents when it's a fraction and the bases are the same? Subtract. So that's the same thing as x to the 3 minus 3 power, which means it's x to the what? What's 3 minus 3? 0. But look at what we started with. If the whatever's on top is identical to what's on bottom, what did we say we could do with any number divided by itself? What is any number divided by itself? What's 5 over 5? What's 100 over 100? What's negative 7 over negative 7? 1. So if I have x to the third over x to the third, what does that have to equal? There you go. That's why anything raised to the 0 power is going to equal 1. Because ultimately, to get that 0 as an exponent, it meant I had that base raised to a power on top that was the same power that was on bottom. Okay? So now we've covered product rule, 0 exponent. Let's talk about what a negative exponent means. Okay? So if I had, and let's see. We'll start it this way. Let's say I had x to the negative 2 power. All right. A negative exponent has nothing to do with the sign of my answer. Instead, a negative exponent tells me something about location. And here's the way it works. A does not look like a fraction. But can I make it look like a fraction? If I put it over 1, I don't know what the number is, but if I put that number over 1, it now looks like a fraction. So here's the thing. If I see a negative exponent, that's telling me I need to flip the fraction or take the reciprocal, because it's telling me this is in the other location in a fraction. So if it started off looking like a whole number a raised to a negative exponent, if I think of it as a over 1, when I flip it, it turns into 1 over a. And when I flip it, then I can use that exponent as a positive. So if I had x to the negative 2, I can think of that as x over 1 raised to the negative 2 power. Now, to get rid of the negative exponent and make it a positive exponent, I got to do what with the fraction? Flip it. So it's going to turn into 1 over x, and now that would be to the positive 2 power. That's all a negative exponent means. It will not turn it into a negative answer. It just tells you you need to relocate it to make it positive. All right? Have you seen those before? Do you remember those? Are those sometimes tricky because you sort of forget what it means? Maybe, if you haven't seen many of them, but we will encounter those some, so we'll have to watch out for them. Now, here are the remaining rules that we've got. A power rule, we haven't used this yet, but it makes sense if you think about it. Suppose we had x squared and I asked you to raise that to the third power. What does that mean my answer would be? Okay, if I think about what exponents mean, Patrick says this is the same thing as x squared times x squared times x squared, because it's telling me multiply that times itself 3 times. Do we already have a rule for how to multiply this? If I'm multiplying and the bases are all the same, what am I supposed to do to the exponents? Add them up. I could break it down even more if I'm still not sure. I know an x squared means x times x, and here's another x times x, and here's another x times x, and if I add all those up, I got how many x's being multiplied together? 6. All right, so all of this equals x to the 6th. Now, you look up there and tell me, what's the shortcut? If I have a power raised to a power, what do I do with the exponents? I multiply them, okay? If they're both bases raised to powers like x squared times x to the third, that's when I add the exponents. But if it's an exponent raised to another exponent, there's got to be a parentheses involved, that's when I'll multiply the exponents, okay? This is just explaining if I have a fraction and there are negative exponents, top and bottom, then again, think about it this way. This is like if I had x to the negative third divided by y to the negative second. Now, I can't use the rule about subtracting the exponents because my bases are different. But I can use the rule about what a negative exponent means. It means take it to the other location and then you can make it positive. So if I flip it, what's going to be on top now? Y to the, what would be the exponent? If it was a negative 2 on bottom, when I flip it, it becomes positive 2. If x to the negative 3 is on top, when I take it to the bottom, it becomes x to the positive 3. Does that make sense? Okay. And so if I've got a fraction in parentheses raised to a power, we made it a fraction earlier before we flipped it. If it's a fraction already in place, like x over m, and that was raised to the negative 2 power, then I can turn it into what? What do I do to the fraction if it has, flip it? And that would turn it into m over x raised to the positive 2. Okay, so that's a quick review of all the different sign rules. Woo! And the exponent rules. We have gone through a lot of information, and it's right about the time we would be normally having a class change. We don't always take a break at this time. Why don't you take a short break? When you come back, I'm going to give you packets, and we're going to start talking about what's in section 1 of chapter 1.